The math over here, and this is the 2014 AIME 1 problem 9. Here's a view of this problem. Let x1 less than x2 less than x3 be the three real roots of the equation root 2014 x cubed minus 4029 x squared plus 2 is equal to 0. Find x2 times x1 plus x3. Okay, so when I first tried this problem, I just looked at this constraint and I immediately thought like pairwise Vieta, because this expands to x1, x2 plus x2, x3. That's everything minus the x1, x3 term. If we can find x1, x3, we're done. But when trying that, I really couldn't figure out a solution on how to do it that way. So I just went on a different train of thought. Let's highlight that over here. So root 2014, the polynomial is root 2014 x cubed minus 4029 x squared plus 2 is equal to 0. Now, of course, the annoying thing is the square root of 2014, right? We'd like to get rid of that. So one thing we can do is maybe for ease of notation, let's just let t equal the square root of 2014, right? So doing that will actually maybe like, and expressing 4029 in terms of t and 2 in terms of t, we can maybe discover maybe a factorable form or something. This is just wishful thinking at this point. So let's do that. Tx cubed, and then how can we express 4029 in terms of t? Well, squaring it we get 2014, doubling it we get 4028, and adding it we get 4029. So negative of what I just said, 2t squared plus 1 x squared plus 2 is equal to 0. Okay, we have nothing better to do other than expanding this. So tx cubed minus 2t squared x squared minus x squared plus 2 is equal to 0. This is an x, okay? What can we do now? Well, let's think about how we can factor this. How about we factor, if we factor it first two terms, last two terms, well, factoring we can say we can take a tx squared common, and then we get x minus like 2t, right? Yeah, x minus 2t, and that has nothing to do with the second expression over here, so that's not probably the way we want to factor it. How about if we consider these two, and then these two? Let's see how that works. Well, we can factor out an x squared here, x squared times xt minus 1, that's good. And then over here we can factor out a negative 2, but nothing more than that. And then over here we get t squared x squared. We can notice that as tx squared minus 1. And then if you don't see it right away, just pause the video and see what can we do here. And then boom, right? We have a difference of squares over here. So let's write that carefully. Xt minus 1 minus 2 times tx, I'll write it as xt because we wrote xt on the other side. Xt minus 1. This is equal to 0. We can factor out an xt1 now. Xt minus 1, and then we get x squared minus 2 times xt plus 1. Or in other words, it's x squared minus 2xt minus 2. This is equal to 0. Okay, so one obvious root will be 1 over t, which is 1 over root 2014. And then the other roots will be resembled by this quadratic. Okay, so how can we solve this quadratic? This is just simply a quadratic in terms of x. We can apply quadratic formula. X is equal to 2t plus or minus the square root of 4t squared plus 8 over 2. Okay, factoring out a root 4, we get root 4 times t squared, root t squared plus 2. That becomes t times root t squared plus 2. 2t plus or minus 2 times root t squared plus 2. Let me just make sure. Yep, that looks good. Over 2. Okay, so we get x is equal to, I'll just write all of them. 1 over t. We can also have t plus root t squared plus 2. And then we can have t minus root t squared plus 2. Okay, so now we have our three roots, and now let's look at our constraints. So we must follow this rule. So let's look at this stuff. What's t minus root t squared plus 2? Well, t squared will be 2014. That's root 2014 minus root 2016. That's negative. Okay. This one over here will be root 2014 plus root 2016. That's positive, all right? And this one is going to be positive, but it's going to be very small. So we can now determine the order. This is going to be our x1, This is going to be our x2, and then this is going to be our x3. Great, and now we can just plug and chug. X2 times x1 is what? It's just 1 minus root t squared plus 2 over t. And then how about now x2, x3? x2, x3 would be 1 plus root t squared plus 2 over 2. Voila, these cancels, and we got our final answer of 2, and we are done.